Hi guys, I welcome you to another episode of Learning Physics with IBM, and today I'm taking you to part 6 of solved past paper questions, force, density and pressure. And without wasting time, I would like to take you to the document, but before we start, do not forget to subscribe, share the videos, download them, like the videos. Um, you can check in the video description for the documents which have the past paper questions. There is a clear video description for any document so that you can print and follow the documents in hard copy. So without wasting time, I would like to take you to the document. Okay, so I think in part 5 we stopped on page 42. I think we stopped on page 42 in part 5. Then in part 6 we should start from page 43. Okay. So a kite is in equilibrium at the end of a string as shown. The kite has three forces acting on it: the weight W, the tension T in the string, and the force F from the wind. Which vector diagram represents the forces acting on the kite? So if this is the string and there is tension, then tension should be away from the kite, and automatically it means that the wind, most likely the wind should be somewhere between these two forces. Maybe the wind should be in that direction there. So this is going to be the direction of the wind. If this is the tension and the weight is vertically downwards, then the wind should be in that direction. If the kite is in equilibrium, there should be a force to balance these two: the weight, the tension in the kite, and the force from the wind, which is called F. So if I try to draw these this as a vector diagram, then I'll have the tension in the string, which is in that direction, and maybe on the head of the tension I'll add the weight, which is W. So this is tension. That means since it is equilibrium, this should point in this direction so that we have a closed triangle. This is going to be the force F. So let's check which vector diagram resembles that. So which vector diagram represents the forces acting on the kite? And I think this is going to be A. So our task was to predict that the tension acts away from the object, and the wind, the force due to the wind should be pushing the object away. So the wind is in the other direction. That's how we come up with this diagram here. So of course they are simple. You can try to eliminate C because it is not a closed triangle. You notice that it is moved like this, but W is the other way around. And also this one is not a closed triangle. If we move like this, W is the other way around. So these two are out because they are not forming closed triangle. Then B, let's see, B is moving. If I move like this, still B is also not a closed triangle, so this is also out. So by just using the fact that for equilibrium, the three forces should form a closed triangle, the answer will automatically be A. So these ones are not forming a closed triangle. They are showing that if we add, for example, T to F, we get W. This one shows if we add T to F, we get W in that direction. This one is showing if I add F to W, I get T in that direction, which is wrong. For equilibrium, the three forces, when joined head to tail, they should form a closed triangle. The density of the air in the atmosphere decreases as the height above the surface of the Earth increases. Density decreases as the height increases. So they are inversely proportional. Which graph best shows the variation with the height h of the pressure P of the air? Okay, so we know that pressure due to a given height is going to be equal to pressure due to a given height is going to be equal to that height. I will use capital H for that height times density times G, where this height here is the height due to the air column. This is going to be the height due to the air column. But remember, the density of the air in the atmosphere decreases as the height h above the surface of the Earth increases. So as small h increases, that is the height above the surface increases, it means the height of the air column above the earth, the surface decreases. What does that mean? Think of a situation when you go up the mountain, or not, I will not use a mountain. Think of the situation when you go above the earth's surface. So let's think of this as the earth's surface, and this is maybe the clouds. The clouds are on this level here. So when you go higher from the earth's surface at a height h, it means this height here becomes smaller. The height of the air column above you becomes smaller. So as this one increases, it means this one decreases. And so the height of the air column, which I called capital H, decreases. But remember, the density is not constant because the density decreases as the height h above the surface of the earth increases. So since the density also decreases, so which graph shall we have? Let's check now by inspection. So this is showing pressure decreases uniformly as h increases. Pressure decreases as h increases, and it is showing that it decreases uniformly. So this is automatically not going to make any good sense, because as the height h increases, capital H decreases. But remember, density is not constant, it is decreasing. So it means the pressure, it is true the pressure decreases, but since these two are not constant, since capital H and rho are not constants, then we cannot have a perfect straight line. So that disqualifies A. Then we have B. B is automatically going to be wrong, because it is impossible to determine H for which pressure is equal to 0. So this this is going to 0. It is impossible for us to determine a value for H for which the pressure is equal to 0. So we cannot really determine that point for which the pressure goes to 0. This could also have been the same thing, the same analogy here. You could use the fact that it is impossible to determine the height for which the pressure goes to 0. So these two could be out. So we remain with the C, and I think C makes more sense. Makes more sense that as H increases, the density decreases. So the pressure is going to decrease because capital H is also decreasing. So since the capital H is decreasing and the pressure depends on the air column above a given point, so capital H is decreasing and the density is decreasing, then the decrease will be more rapid. So the pressure decreases more rapidly. So it makes sense to say that the answer is going to be C. This one shows the pressure decreases slightly, then more rapidly, then slightly. We cannot rely on this, so I'll consider the answer to be C, because the height of the air column above a given point decreases as the h from the surface of the earth increases. The density is also decreasing, the pressure decreases more rapidly, so the answer is going to be C. A flat metal disc has a radius r, forces of magnitude F are applied tangentially at the edge of the disc. The forces are in the plane of the disc. Which arrangement of forces produces only a torque of 2Fr? Okay, only a torque of 2Fr. So we know that torque is the product of one of the forces and the perpendicular distance between them, or it is the moment of a force is the product of a force times perpendicular distance. So let's check. This is clockwise, this is clockwise. The total here is going to be F times the distance from the center, which is R, plus F times the distance which is from the center, that is R. So which arrangement of force produces only a torque of magnitude 2Fr? A torque of magnitude 2Fr. A flat disk has radius r. Forces of magnitude F are applied tangentially to the disk. Okay, so this is causing that rotation. So this is twice Fr, which is clockwise, and B, this is going to be the product of one of the forces times the perpendicular distance, which is 2r, that gives us 2Fr, and C, this one automatically will give us more than 2Fr, this one will give us more than 2Fr. Now we have to choose between these two. The forces are in the plane of the disk. They are in the plane of the disk. Which arrangement of forces produces only a torque of magnitude 2Fr? So the answer is going to be B, because these two forces constitute a couple. So they are producing a torque of magnitude 2Fr, but there is no resultant force. Resultant force here is 0. Yet for these ones, they're acting at right angles. They are producing a torque of 2Fr, but the resultant force here, force resultant, is not 0. So the answer is going to be B. These ones are at 90 degrees. The resultant can be obtained by Pythagoras theorem. The diagram shows the jib of a crane at an angle of 35 degrees to the vertical. A cable passes over a frictionless pulley and carries a load of 1830 newtons. The force R that the pulley exerts on the cable is in line with the jib. The cable and the pulley are in equilibrium. So this is very important, in equilibrium. What is the value of R? So I'm just going to resolve these forces downwards along this direction, along the same line as R, but in opposite directions, so that I get the resultant of these two should be equal to R for equilibrium. So since each has a force of 1830 newtons, so when I resolve 1830 in this direction to be 1830 cos of 30, similarly for this one should also be 1830 cos of 30. So it means R, the other side, should be the sum of these two. So it is 2 times 1830 cos of 35. When I check this with my calculator, 2 times 1830 cos of 35. So this is 2998 point something. So that is approximately 3000 newtons. So the answer is going to be D. What is the unit for density? Of course, we need per meters cubed. You can't take this one because there is no, you can check Newton is kilogram meters per second squared. So in density, we shall not have seconds. Gram per millimeter, it can't be per millimeter. Kilogram per centimeter squared, that is wrong. So per millimeter cubed is fine. Milligrams, this will be mass. The other one will be volume. So, I mean, this is mass divided by volume because of -3. So the answer is going to be D. On a planet, a gravitational force F acts on a mass of 6 kilograms. The mass is moved by force F, a distance of 30 newtons in the direction of the gravitational field. The work done by the field is 450 joules. What is the force F on the mass, and what is the acceleration of free fall G on the planet? Okay, so to begin with, the work done is 450. Work done is equal to force times distance, which is 30. This means the force is 450 divided by 30, which is 15 newtons. So the force is 15 newtons. We ignore A and B. Then, what is the force on the mass and what is the acceleration of free fall? So from force, resultant force is equal to mg So mg is equal to 15. So the acceleration of free fall is going to be 15 divided by the mass, which is 6. And I think this is automatically 2.5. So the answer is going to be C. A uniform meter roll of weight 2 newtons is pivoted at the 60 centimeter mark. A 4.0 Newton load is suspended from one end, causing the roll to rotate about the pivot. Okay. At the instant when the roll is horizontal, what is the resultant moment about the pivot? Okay, so a uniform meter of weight, 2 newtons. So the weight acts, it is uniform, the weight acts at the midpoint. It is pivoted at the 60 centimeter mark. So it is at 60 and it is a meter roll, so the weight is at 50. The weight of the meter roll of 2 newtons is at 50. So from 50 to where the pivot is, that is 10 centimeters, that is 0.1. That is 0.1 meters. Okay. So at the instant when the roll is horizontal, what is the resultant moment about the pivot? So let's check the clockwise moment. The clockwise moment is going to be this one here. This one is causing clockwise about the pivot. So that is 4 newtons times the distance, which is 60 to the extreme end. This distance is going to be 40 centimeters or 0.4 meters. So this is times 0.4. That is clockwise moment, which I think is 1.6 Newton meters. Then the anti-clockwise moment is going to simply be the weight of the rule, which is 2, times the perpendicular distance from the pivot, which is 0.1, and I think this gives us 0.2 Newton meters. So the question is at the instant when the rule is horizontal, what is the resultant moment about the pivot? So the resultant moment is going to be 1.6 minus 0.2, which is 1.4 Newton meters. So the answer is going to be B. The vertical forces that the ground exerts on a stationary van are shown. The van is 2.5 meters long with the wheels at a distance of 0.6 meters from the front of the van and 0.4 meters from the rear of the van. What is the horizontal distance of the van's center of gravity from the front of the van? So let's just position the center of gravity somewhere within the van. Let's say the center of gravity is at this point here. That means its weight acts at that point. And what is its weight? From equilibrium, its weight is going to be 16,000 plus 9,000 up, because those are the forces acting upwards. So 16,000 plus 9,000. So the weight of the van downward, the force downwards, is going to be 25,000 newtons. That is the force downwards. Okay. So the van is 2.5 meters long with the wheels at the distance of 0.6 meters from the front of the van and 0.4 from the rear view. So I'm going to take moments about this front wheel here, taking moments about the front wheel. So let me start with the clockwise moment. If I take moments about the front wheel here, the clockwise moment is going to be equal to this. The 16,000 has no moment. I will say the distance from the center of gravity to the front wheel is x. So taking moments about the front wheel, the center of gravity, the weight through the center will cause it clockwise, and the 9,000 will cause anti-clockwise about the front wheel. So clockwise moments will be 25,000 times the perpendicular distance, which I've called x. So times x, 25,000 x. Then the anti-clockwise moment would be 9,000 times the perpendicular distance, which is 1.5 I think it is 1.5. So this is times 1.5. That is the distance between the rear wheel and the front wheel. That is 1.5 meters. So I tried for equilibrium, these two are supposed to be equal. So I'll simply say x is going to be equal to 9,000 times 1.5 divided by 25,000. So we have 9,000 times 1.5 divided by 25,000. So this is 0.54 meters. So the question is, what is the horizontal distance of the van's center of gravity from the front of the van? The front of the van is 0.6, so we shall just add the distance which we want will be 0.6 plus 0.54, which I think this is 1.14 meters. So the answer is going to be C. An object hangs by means of two cords around two rods as shown. The object is held in equilibrium. That is very important. The object is held in equilibrium by the forces F1 and F2. The object weighs 10 newtons. So if the object weighs 10 newtons, so there is a force downwards which is 10 newtons. There is a negligible friction between the rods and the cords. Angle theta is 90 degrees. So if angle theta is 90 degrees, if I draw a horizontal line here, then this should be 45 degrees, and this should also be approximately 45 degrees. So which row of the table gives an angle theta of 90 degrees? Okay. Which row of the table gives an angle theta of 90 degrees? So F1 of 4 newtons. I'm going to try and resolve this in the horizontal and see what this gives us. So resolving in the horizontal, or let me resolve in the vertical since I'm given the weight 10 newtons downwards. So let this, of course, this is going to be F1 because this is F1. This is the tension there is going to be F2. So resolving F1 vertically upwards, I have F1 cos or sine, whatever, because cos of 45 is the same as sine of 45. So F1, let me say sine of 45 plus F2 sine of 45 should be equal to 10. So which row of the table gives an angle theta of 90 degrees? So we are going to check. I'm going to use inspection. So let's check with our calculator. Suppose F1 is, I'll just check C because the values in C, they are making good sense to me. So you can check the rest. I'll check C. So 6 sine of 45 plus 8 sine of 45. If this gives us 10, then that row is going to be correct. So this is giving us 9.89, which is approximately 10. Okay. So I think the answer is going to be C. That is 6 sine of 45 plus 8 sine of 45. It should give us 10 or approximately 10. We can check. So now here I see that there are two values the object is held in equilibrium by the forces F1 and F2. The object weighs 10 newtons. There is negligible friction between the rods and the cords. Angle theta is 90 degrees. So angle theta is 90 degrees. Now, if we check this, let's check the horizontal. Of course, the horizontal 6 sine 45 should be equal to 8 sine of, let's check. In the horizontal, when I resolve this to the horizontal, maybe let me just do this manually. Let me assume we don't know that angle. Let this be theta 1 and let this be theta 2. If I resolve f1 in the horizontal, I have that f1, or maybe let me use these angles, theta 1 and this is theta 2, rather than using the ones in here. Okay, so f1 to the horizontal, f1, when I resolve f1 in the horizontal, it will be f1 cos theta 1. Then this should be equal to the other side, to be f2 cos theta 2. Okay, then when I resolve in the vertical, it will be f1 sine theta 1 plus f2 sine theta 2. This should give us 10. So when we combine these two, of course, theta 1 plus theta 2 should be equal to 90 degrees. Theta 1 plus theta 2 should be equal to 90 degrees. So that means I can just remove 1 and I say, okay, theta 1 should be equal to 90 minus theta 2. So I can just use theta 2 throughout. So I have two equations. The first one, I have that f1 cos of 90 minus theta 2 should be equal to f2 cos of theta 2. Of course, cos 90 minus theta 2 is the same as sine theta 2. So f1 sine of theta 2 is equal to f2 cos of theta 2. Alternatively, I can say that f1, or I can say that f2 should be equal to f1 tan of theta 2. So f2 is f1 tan theta 2. Alternatively, I could just substitute in this expression here. I could just substitute in this one here. Of course, f1 sine, I'm removing sine, I'm removing theta 1, so I will have f1 sine of 90 minus theta 2 is going to be cos theta 2. So this is f1 cos theta 2 plus f2 sine of theta 2 should be equal to 10. So now I have two unknowns and two equations. I should be able to solve these two equations. If you want, you can substitute, or you can remove one of these. You can remove what should I just use this here? Okay, so as a mathematician, I expect that you can solve this mathematically and see what you obtain. However, we can check using inspection using these values. Suppose f1 is 8 and f2 is, suppose f1 is 6 and f2 is, if f1 is 6 and f2 is 8, let's check. So it means tan of theta 2 is going to be equal to f2, which is 8, divided by 6. 8 divided by 6. So shift tan of the answer, that is 53. So it means f2, if we take f1 as 6 and f2 as that, it means theta 2 is going to be 53 degrees, which means theta 1 is going to be approximate. If the other one is 53, then this one is going to be around 20 or 37 degrees. Theta 1 will be around 37 degrees. But you can check when it is the other way around. You can check when you have 6/8 and see what you get. But basically the answer is going to be this one here by simple examination. Which force is caused only by a pressure difference, that is automatically upthrust? So upthrust is the one which is caused by a pressure difference. A sphere is acted upon by various forces, all of the same magnitude. Which system of forces provides a resultant torque but zero resultant force on the sphere? Which system of forces provides a resultant torque but zero resultant force? So let's check. So here, this is anti-clockwise, clockwise. There is no moment there, but there's a resultant force. So here there's a resultant force. Then here, this cancels out. Here there is a resultant force because this can cancel out with this one, but there is this one here. Here there is zero resultant force, but still there is no moment. So moment is zero, resultant force is zero, because these two forces are acting in line, so there is no resultant moment. So this is also out. So it means the answer is automatically D, because these two forces cancel out, so there is no resultant force. But this causes an anti-clockwise moment about the center, and this one causes no moment about the center because it's acting through the center. So there's a resultant moment. The resultant moment is not zero, but the resultant force is zero. So the answer is D. Torque, when I write torque, that is moment is not zero, but there's a result. The torque is not zero, but the resultant force is zero. A uniform horizontal footbridge is 12 meters long and weighs 4,000 newtons. It rests on two supports, X and Y. A man of weight 600 newtons is a distance of 4 meters from support X. What is the upward force on the footbridge? Upward force on the footbridge from support X. So we want the force here. So since we want the force there, I will take moments about position Y. Since I want the force there, I will take moments about position Y. So there's weight of this man. Then there is weight, it is uniform, its weight acts at the center. So this is 4,000 newtons. That's the weight of the bridge. And the man has weight 600. So this is 600. This distance here is half of 12. So this is 6 meters. So the distance from the other side is 6 meters. The distance of the man to the other support is going to be 12 minus 4, which is 8 meters. Okay. So the man about support Y, this is clockwise, this is clockwise. The force here is going to cause, sorry, this is anti-clockwise. Anti-clockwise, the force from X is going to cause a clockwise moment. So we take moments about Y. So the force at X times its perpendicular distance, which is 12, should be equal to 600 for the man times perpendicular distance, which is 8, plus 4,000 for the bridge times its perpendicular distance, which is 6, from the point where we're taking moments. So when I check this with the calculator, I have 600 times 8 plus 4,000 times 6. Then I divide this by 12. So this is 2,400 newtons. So it means my answer is going to be C. A metal block has a mass of 750 grams. 60% of the mass is magnesium and the remainder is copper. The density of magnesium is 1.7 grams per centimeter cubed. The density of copper is 9 grams per centimeter cubed. What is the density of the block? So this is like a mixture, and we have said density of the mixture, which I will call, now the block is the mixture. So the rest of the mixture of the block is going to be the total mass, I'm calling it MT, over the total volume, I'm calling it VT. So the total mass, the metal block has a mass of 750 grams, so total mass is 750 grams. Now total volume, it has 60% of the mass, magnesium, and the remainder is copper. So remember, volume is equal to mass over density. So I'm now getting total volume. For magnesium, it is 60% of M. So this is, the volume is going to be 0.6 of the mass, 0.6 of the mass, that is 0.6 times 750. This is divided by the density, which is 1.7. This is the volume for magnesium, plus the volume for copper, its mass is going to be 40%. So that is 0.4 times 750 divided by its density, which is 9. So I just press my calculator. I will start with the denominator. 0.6 times 750 divided by 1.7 plus 0.4 times 750 divided by 9. Sorry, yes, 9. Then I will say 750 divided by the answer. So this is giving me 2.5. So the density here is 2.5. Total density is 2.5 or 2.52 grams per centimeters cubed. So this makes the answer to be A. Note that I used the volume as mass over density in the denominator because I was finding total volume. This is the volume for magnesium plus the volume for copper to get total volume. Total mass was given as 750 for the block. A metal cylinder is suspended vertically in equilibrium by a cord. The diagram shows the cylinder in 4 different positions, P, Q, R, and S. Which statement explains the variation of the tension T in the cord? Of course, the tension is going to be greatest when it is in position S. It is going to be smallest when it is in position P. When it is here, actually when it is position P and Q, the tension is the same because the upthrust is constant. Then here, the upthrust slightly reduces. The upthrust reduces here because of the smaller part which has been submerged in the water. And here, the tension is going to be greatest. Okay, let's see the values here. Because remember, upthrust depends on the cross-sectional area times difference in pressure, which difference in pressure depends on the density, G, and the height which is submerged. Difference in the height from the top and the bottom of the object which is submerged. Okay, let's check the options. At P and at Q, the tension in the cord is the same. I think I mentioned that. The difference in the pressure between the top and the bottom of the cylinder is the same. That statement is correct. So the answer is C. Because the upthrust depends on the pressure between the top and the bottom of the object, not where it is, not the depth where it is, but the difference between the top and the bottom of the object, then it means the upthrust in position P and Q is the same. So the answer is automatically A. I will not check B, C, and D. In a machine, many couples act on a rotating object as shown. Okay. What is the resultant torque acting on the rotating object? Okay, let's check. So I'm going to assign clockwise moments positive and anti-clockwise moments negative. If the resultant is positive, I know I just need anyway the magnitude, so there's no problem with that. So the torque here for the resultant, the moment is going to be, so I am starting with the clockwise moments first. but I see there are more anti-clockwise moments. So let me make anti-clockwise moments positive, clockwise negative. So this is clockwise, that is anti-clockwise. Its distance from the center, this one and this one, we can say they are 2. So we get the torque due to this and this is going to be 2, or it's going to be one of the forces times the perpendicular distance between them, which is the diameter of this circle. That is 12 times 2, that is 24. So that is times 0.24 plus. We have 16 and 16. These are acting, causing a couple. The distance from the center is 10 centimeters. So the diameter from here up to the other end is 20. So we shall say 16 times 0.2 plus. The next one is, we have 30 and 30. This one is acting the other way around. So I'll first leave that. We have 50 and 50. So it will be 50 times perpendicular distance. The distance is this one here, which is the diameter of that small circle. 4 centimeters is the radius. So it is 4 times 2, 0.08. So this is going to be 0.08 meters. Then I think those are all anti-clockwise. Then I'll say minus the clockwise. Clockwise, we have 30. It is causing a couple, which is clockwise. So we shall say minus 30 times the perpendicular distance between them, which is 6.5 plus 6.5. That is 13. So that is 0.13. So I'll just press the calculator to see the resultant. So 25 times 0.24 plus 16 times 0.2 plus 50 times 0.08 plus, minus 30 times 0.13. So this is giving 9 over 10, which is 9.3 Newton meters. Of course, this total sum, I think the total sum of the anti-clockwise moments is bigger than the sum of the clockwise moments. So I think the answer would be anti-clockwise, but the magnitude is 9.3. A uniform beam is pivoted at P as shown. Weights 10 newtons, 20 newtons are attached to its ends. The length of the beam is marked at 0.1 meter intervals. The weight of the beam is 100 newtons. At which point should a further weight of 20 newtons be attached to achieve equilibrium? Okay, a further weight of 20 newtons be attached to achieve equilibrium. So it is uniform, its weight is at the midpoint. So this is 1, 2, 3, 4, 5. Its weight should be here. The weight of the beam is 100 newtons. Okay, so the total weight this side and is most likely greater than the total weight the other side. So it means the other weight should be placed this side. So let me say I will just randomly say okay, it is placed here. And let this distance from the pivot be x. And this weight is 20 newtons. Okay. So at which point should a further weight of 20 newtons be attached to achieve equilibrium? So I want the distance x from the pivot. Should it be at A, B, C, or D? Let me just assume the distance this side is x. So we have 20 times the perpendicular distance, which is 0.4, plus another 20 times perpendicular distance, which is x. So these ones will cause clockwise moments. This should be equal to the other side, which is 100. Perpendicular distance here is going to be 0.1. Because this is the midpoint, this is 0.5, so this is times 0.1 plus 10 newtons times perpendicular distance, which is from here up to 0.6, so this is times 0.6. So I'll just check with my calculator. 100 times 0.1 plus 10 times 0.6, then I'll say minus 20 times 0.4 divide by divided by 20. So that is 0.4. So x is equal to 0.4 meters. Therefore, it should be placed 0.4 meters at position D. So the answer is D. What are the SI base units of the quantity pressure divided by density? Okay, for pressure, remember pressure is force over area. So that is force is kilogram meters per second squared over area, which is meters squared. So this becomes cubed. Kilogram meters per second squared, that is force, over area, which is meters squared. So this is power 1 minus 1. You have meters divided by meters squared. So that is m power minus 1. That is pressure divided by density, which is kilograms per meters cubed. So this cancels out. M minus 1 divided by m minus 3, that is m power 2 s minus 2. So the answer here is going to be D. A uniform beam of mass 1.4 kilograms is pivoted at P as shown. The beam has a length of 0.6 meters and P is 0.2 meters from one end. Loads of 3 kilograms and 6 kilograms are suspended 0.35 meters and 0.15 meters from the pivot as shown. What is the torque that must be applied to the beam in order to maintain equilibrium? Okay, so let's begin with the clockwise moments. Clockwise moments, we have 6 is causing clockwise. So it is 6 times this is mass times g times 9.81 times the perpendicular distance, which is 0.15. That is clockwise. So this is going to be equal to 6 times 9.81 times 0.15. So this is 8.829 Newton meters. That is clockwise. There is no any other clockwise here. So this is the center of the beam of mass 1.4. So the weight of the beam acts here, which is 1.4 times g. So let's check anti-clockwise moments should be equal to, we have this one, which is 3 times 9.81 to change it to weight. Its perpendicular distance from the pivot is 0.35 plus the weight of the beam 1.4 times 9.81 times its perpendicular distance, which is this one here. So this is which distance is this? Remember, this was the center of the beam. This was the center of the beam, and the center of the beam from the other end of 0.6 divided by 2, this is 0.3 meters. So 0.4 minus 0.3, that is 0.1. So this distance here is 0.1 meters. So this will be times 0.1 meters. So let's check this with the calculator. 3 times 9.81 times 0.35 plus 1.4 times 9.81 times 0.1. So that is 11.6739 Newton meters. So we want the difference will be the resultant, the torque which is needed to maintain equilibrium. The resultant is the difference. I'll just subtract that minus 8.829, which is 2.8, which is approximately 2.8 Newton meters. So the answer is going to be D. That is the torque needed to maintain equilibrium. Because this is the resultant, we need to overcome that resultant for equilibrium. An air bubble is raising through a liquid at constant speed. Resultant force should be 0. The forces on it are upthrust, the viscous drag D, and its weight W. Remember, if it is raising through a liquid, the upthrust remains constant, the weight remains constant. Since the speed is also constant, then it means the viscous drag is also constant. So since it is raising, the drag must be downwards. So it means we eliminate D. Because movement is upwards, the drag must be downwards. So D must be downwards. So we eliminate part D. Then the resultant, remember, should be 0. So the weight acts downwards plus the drag downwards should be equal to the upthrust upwards. When I add the weight and the drag, I should get the upthrust upwards. So when you measure the magnitudes and combine, you notice that the answer is A. Try to measure this length here for the upthrust, then measure the one for the drag plus the one for the weight and see. This one will be relatively shorter than the one at the top. This one will be, I think this will be much great. It could be much greater than the one at the top. So the answer is going to be A, not C. You just compare the magnitudes. So the answer is going to be A. The diagram represents a sphere underwater. P, Q, R, and S are forces acting on the sphere due to the pressure of the water. Okay. So the sphere is underwater. Each force acts perpendicularly to the sphere's surface. P and R act in opposite directions. Q and S act in opposite directions. Which information about the magnitudes of the sphere, the forces is correct? Of course, the P is acting at the top and R is acting at the bottom. It means the force P is greater than the force R is greater than the force P because remember, pressure is equal to force over area, and the pressure at R is greater than the pressure at point P. So it means the force at R is greater than the force at P. But the force at S is the same as the force at Q. Also, you should note that the force at S is the same as the force at Q, but this force is less than the force at R. I think that makes sense to us. So let's see what is there. Which information about the magnitude of the forces is correct? P is less than R. That is very true. P is at the top. The pressure increases with depth. So the pressure at the bottom is greater than the pressure at the top, meaning the force at the bottom is greater than the force at the top. S and I think I mentioned that S and Q are equal because it is on the same level. So the answer is automatically going to be A. I will not check the rest. A block is submerged vertically in a liquid. The four diagrams show to scale the forces exerted by the liquid on the block. Which diagram correctly shows a possible situation as viewed from the side? A possible situation as viewed from the side. So if we view from the side, it means the forces go on decreasing, but they remain the same at the top, because if I'm viewing from the side, let's say we are viewing from this side here, because pressure increases with depth and pressure is force over area. At the bottom, it is the same level, the force is the same. At the top, same level, the force is the same. But when you view from the sides, the depth goes on increasing, meaning the pressure goes on increasing, so the force goes on increasing. So it means this is correct. When you view from the side, the force, of course, this is fine, but the forces on the sides goes on decreasing. So it means this is out. Um, So this is also out, because if this is the force at the top represented by these arrows, then the force here, this arrow here should be closer to that one in magnitude. So this one is wrong. It is showing that the length of these arrows are the same as the ones at the top, meaning that the force is the same on this side as you go to the bottom, and then it becomes higher when you are exactly at the bottom. That is not true. This one was disqualified because of the size of this arrow. It means if this was representing the force on the top, then this arrow here should be very close in height in length with this one, and should go on increasing, not becoming smaller than that one. So this is the most correct diagram, because this arrow is showing that this arrow is almost the same as this one, and the force goes on increasing, and at the bottom it is almost the same as the length of these arrows. So the answer is going to be A. The diagram shows a motorist vehicle carrying one person. You can see the person here enjoying. The vehicle has two wheels on axle. On one axle, the passenger stands on a platform between the wheels. The weight of the machine is 600 newtons. Its center of mass is 200 millimeters in front of the axle. The wheel radius is 400 millimeters. When stationary, a passenger of weight 600 newtons stands with his center of mass 200 millimeters behind the axle to balance the machine. The motor is now switched on to provide a horizontal force of 90 newtons at the ground to move the vehicle forwards. How far and in which direction must the passenger move his center of mass to maintain balance? Okay, let's go back to the diagram. So number one, the weight of the machine is going to be exerting a clockwise moment. And what is this moment? So the weight of the machine will exerts a clockwise moment. I will try to calculate this moment. So the weight of the machine exerts clockwise moment, which is equal to that was 600 times the perpendicular distance. They said the weight of the machine is 600. Its center of mass is 200 millimeters in front of the axle. So I'm going to take moments about the axle. So this is 600 times 200 millimeters. I will not change the units. I'll just say 200. So that is, the answer is going to be newtons millimeters. Then the weight of the man. The weight of the man should be now exerting. So exerts anti-clockwise moment, which should be the man has a weight of 600 newtons and also stands 200 millimeters from the center of the axle. So this is times 200. Okay, so the machine exerts a force of 90 newtons in direction of motion. The machine exerts a force of 90 newtons in direction of motion. In the direction of motion, what does that imply? If the machine exerts a force of 90 newtons in the direction of motion, then if it is not the force is not acting through the axle, then it is going to be providing, if it is acting in this direction here, then with respect to the position to the axle here, then it is providing so the machine exerts a force of 90 newtons in the direction of motion. So this should be providing a moment which is going to be 90 times the perpendicular distance. What was that perpendicular distance? That is 400 that is going to be 400 if the machine exerts a force of that. So I'm going to take moments about this point here. So if the machine exerts a forward force in that, taking moments about here, it is going to be, I think this is going to be a clockwise moment, I guess. So this is going to be the moment due to the machine, which is equal to 90 times 400. Okay. So to maintain balance, of course, the anti-clockwise moments should be equal to the clockwise moments. So for balance, anti-clockwise moments should be equal to the clockwise moments. So for the anti-clockwise moments, I have the weight of the man, which was 600 times 200. That was the weight of the man causing an anti-clockwise moment. So this should be equal to the clockwise moment, which will be 90 times 400, because if the machine exerts a force in this direction, then about this point is causing, taking moments about this is causing a clockwise moment. So this is going to be 90 times 400 plus the other anti-clockwise moment, which should be 600, that is for the weight of the machine, times, because we want now, the question is how far and in which direction must the passenger move his center of mass to maintain balance? How far must the passenger move his center of mass? Okay. So if the machine, if the man causes an anti-clockwise moment, which is equal to that, but how does this machine act? The motor is now switched on to provide a horizontal force of 90 newtons at the ground. Sorry, the force is at the ground, so this is anti-clockwise, so I have to rub off this. So if the force is 90 at the ground, taking moments about this center, then this is going to be anti-clockwise. So this is anti-clockwise. So let me just consider this to be for the machine, which is 600 times 200. And then this is for the motor, plus now this is going to be the man. If he doesn't move his mass, if he doesn't move his center of mass, is supposed to be at 200. If he moves his center of mass, then should be at 200 minus a distance x. So I'm going just to find x. So this would be 600 times 200 minus 90 times 400 divide by 600. So I'm going to make, I have 140 is equal to 200 minus x. So it means x is going to be equal to 60 millimeters. Okay, so I think that is true. If the motor exerts a force of 90 newtons on the ground, taking moments above the axle, this force causes an anticlockwise moment. And remember, the man was also exerting an anticlockwise moment. Then the weight of about this point here, the weight of the machine was causing that moment in that direction, which is clockwise. So to maintain equilibrium, the sum of clockwise moments should be equal to the sum of anticlockwise moments. That's how I arrived at x as 60 millimeters. So let's check the answers there. So we ignore C and D. Now we have 60 millimeters. Is it 60 millimeters forward or 60 millimeters backward? Of course, I said 200 minus x. So it means that is forward. If I had got a negative out, it would automatically be backward. So this is going to be forward. Because I said 200, it was already standing 200 millimeters from the center of from the axle. So I said 200 minus x. So that means it moves forward. The distance becomes smaller. So it is 600 millimeters forward. Okay, let part 6 stop here. We shall start from here in part 7. See you. Bye bye.